Go ahead. Yeah. So very good morning to all of you, and good morning and good evening to all of you. So a little bit of housekeeping to start with. All attendees will be on mute, and we request to keep on them to keep on mute. If you have any questions, please enter it in chat box. If you are experiencing any technical glitch, please try exiting and rejoining. So the usual stuffs. So a little bit about Data Code. Our mission is Data Code is a leading organization in field of geoscience industries, and we are bringing cutting edge technology and services to the industry. Now it's more than 25 years we are into the market now. Our mantra is we believe in 3 E's, and which is empowerment of end users, enhancement of employee skill sets, and equity to all stakeholders. About this program, which we started, it's a team initiated with an objective to share knowledge within the geoscience domain to the community for better reach of the subject. We call it as Partners in Progress. And this, we hope this session will empower students and professionals from the industry, and thereby it will create a wealth of knowledge for the society at large. Now coming to today's topic and today's speaker, today we are joined by Asmita Mahanta. She is a geophysicist by background. After completing, she is working in the resource sector now for more than 25 years in this industry. After completing her tertiary studies in geophysics from IITS and from Dhanbad in India, Asmita started her career from Udaipur in Rajasthan, exploring for base metals. She moved to Australia in 2000. During her career with a major Australian resource company, she has gained extensive experience with various geophysical techniques as well as numerous commodities, including iron ore, copper, gold, other base metals, kimberlite, coal, and uranium, so lots of commodities. Currently, she leads a multidisciplinary team of technical specialists, establishing technical standards, data quality standards and processes, and implementing technologies to uplift productivity and unlocking resource value. Her passion include inclusion and diversity, embedding technology and building a team and process capabilities for future generations, for future geosciences. So on behalf of Data Code, I welcome ma'am for you for today's talk. Over to you, ma'am.
Thank you, Dhruva, for the introduction. I will try to share my screen now. Can you see my screen now?
Yes, ma'am. You can see.
Great. Thank you, everyone. It's a pleasure to be here today with you, and really glad to have the opportunity to talk about data, geosensing data, and quality.
Just a second. Let me mute all the parts.
Yeah, so geosensing data and quality, it's something really important to me. So before I begin, just quickly putting a disclaimer that I'm talking here today as an individual and not representing any company. I'm a geophysicist, as Dhruv said before, by training, but I've been very fortunate to work with a multidisciplinary team. It's not just geophysicists, but geochemists, geometallurgists, database professionals, structural geologists, and learn about all facets of geoscience. But most importantly, the potential of integrating various types of geosensing data. You know, when I started 25 years ago, we used to work a lot in silos. Geophysicists will work with geophysics data, hand over to the geologist, but changing. So every day I watch with great pleasure to see how our working culture is slowly changing. We are slowly starting to work together. more in collaboration with each other, with a view to solve problems and continuously improve our resource knowledge. And that's why all of us are here. The better resource knowledge we can have, we can make our downstream operations safer and more efficient. So, today I will be talking about geosensing data, but the boundary is the exploration and mining. I won't be talking anything around oil industry data. So I'll start with some discussion on mining value chain and then talk about geosensing data across that value chain and data quality. And we'll wrap up with why data quality is non-negotiable. And this is something I always insist. The quality of data is absolutely non-negotiable. And most of what I'll talk today, I do hope that you already know about it. But it is very important to keep that conversation about data quality going. We don't talk about data quality as much as we should be. And with the advances in technology, especially in the field of big data, machine learning, and predictive analytics, ensuring data quality of our data becomes even more critical than ever. So let's talk about mining value chain. So I'm not biased as a geoscientist, but I will say that it starts and ends with geology. So the way I summarize it, I feel that mining value chain is essentially made up of three parts. Firstly, the what, and this is the resources in the ground, the geology, structure, and the ore body. And this is the foundation of every mining company upon which they build their future. And if you think of it, resources make up typically 60 to 90% of a company's business value. And the remaining value is realized through the extraction process and, of course, the market. And without the resources on ground, there is simply no value. And this is where we should put a lot of emphasis on getting the early ore body knowledge to ensure we can maximize the value through the value chain. So knowledge of geology and ore body informs every part of the value chain. It starts from the fundamental decision to initiate and continuing exploration through to mine design, infrastructure planning, logistics, market strategy, and through to the closure of the asset. So the resource knowledge helps us with the critical decisions in many ways. I'll just go through a few. To start with, the geology, overburden knowledge, stratigraphy, structure, they all define the size, the volume, and the complexity associated with the deposit. Then we have the physical property, such as density, to calculate tonnage, which determines the life of the mine, but also define the fleet and the mining infrastructure design requirement, and so many other things associated in setting up a mine. And then chemical properties of the body, ore body. It's the grade, and grade is the king, as we all know, to define marketing strategies and inform product quality specification for the customers. Then we also need to know mineralogical and geometallurgical properties to ensure that we use the suitable extraction process, that our plants are built for the appropriate ore envelope, and use the knowledge for planning and scheduling. And then metallurgical properties, because we need to be able to tell how our material is going to behave when we put it through a processing plant, not just ours, but for our customers as well. And then we need to know about water table, how much water we have, how much of our ore body is above or below water table, then we need to be able to give fit for purpose data for our geotech friends so that they can build the walls to provide safety as well as optimal ore extraction. And then there are other properties such as hardness, moisture, porosity. So I can go on about this, but these are some of the very useful ones. And these all drive ultimately our financial decisions. So that's the first part of the mining value chain. The second part is the how. So once we know what's on the ground, next part of the value chain is how we optimally extract that material and turn it into a product. At the end of the day, we have to sell a product and make money. So this involves a mining process, mine planning. What is the best sequence of digging? How do we design our pit? How steep we can make our walls so that it's safe, but yet we have to move less dirt. Every 1 degree steepening of a pit wall can generate millions of dollars. And how many mining machinery we need? And then can we actually optimize our rock fragmentation in our drill and blast operation if we know about our drill ore body well and the hardness. And then to processing. We don't want any delays due to material handling issues. If we can actually preempt that, we can put processes in place to mitigate that risk. And then how do we maximize our ore extraction? But we have to remember that every action, decision taken or not taken at each stage or any knowledge gap at each stage will have a flow-on effect onto the next stage. So, in a nutshell, efficiency of every part of how is dependent on what. And that is the ore body knowledge or the deposit knowledge. Finally is the why. And why is obviously the market. It's all about supply-demand balance, and it drives the what and how. Demand will trigger more exploration, definition, and new mines. And at the end of a mine life, we have the last, but not the least important bit, closure. We have to look after environment, and hence closure is very, very critical. So that's, in a nutshell, is our mining value chain. And enormous amount of data and knowledge is gathered and generated across the value chain. But the important question here for all of us, the geoscience professional, is that can we rely on the data that makes the basis of such important decisions? So do we know the source of our data? Do we have the right data to make all these decisions? Do we have enough data? Do we know how well the sample data represents the population? Have we defined the outliers in our data? Is there any bias? Can I vouch for my data quality and integrity? Can I access my data easily? I hope all of you who look at data, analyze data, build model with data, or make decisions with data, you should be asking these questions every day. And it's really important that you do ask these questions. So now, what are some of the data that we collect across the value chain? So as I said, we collect a huge amount of data across the value chain. And as I said before, I'll just restrict myself to the geosensing data because there is enormous amount of data collected across the value chain. If I start talking about everything, it will take me the whole day. But let's just talk about geosensing. So when I say geosensing, I mean the measure or infer various rock properties at various scales using different types of scanning devices. So if you start at the beginning, we often start data gathering in an exploration project with ground geological recce survey, if possible, if the ground permits us. And then usually we follow up with an airborne survey or ground geophysical survey. It can be aeromagnetic or gravity gradiometer or hyperspectral EM. It can be anything. And it can be field mapping. We map for geology and structure. So using this data set, we can start building our first understanding of the geology and the structure. Some of you may have heard Mark Jessel's talk last week or week before. I always enjoy listening to Mark talking, especially about 3D geophysical constraint inversion and uncertainty mapping. So using our first regional data set, we can start building a model like that, a solid earth model with various geological, geophysical, and mineralogical properties that we have gathered. So then when we have our solid earth model and we have oogenesis data, the focus of the next step is often some ground truthing. We go and check it on the ground. Is it what we think is there, or we do some other geophysical survey? So that's kind of the sort of non-evasive remote sort of survey. And then when we know where our target is, next step is go and drill a hole. And this is where we either collect a lot of samples and also, not always, but in most cases, we go and collect downhole geophysical data as well. The most common ones for iron ore are gamma, density, magsas. We have neutron activation tools, resistivity, teleview, optical acoustic, and coal also use some of these. So in exploration phase, probably we don't use downhole tools as much, but as we move more towards brownfield exploration, we need all these tools for physical property definitions. And once we collect the data from our drill holes, that is often sent to the lab. And at the lab, again, we collect grain density, porosity, or chemical assaying, XRF, hyperspectral, size distribution, all this data, another set of data set we collect. And then once we have our resource definition, we go to the mining phase. And then we again collect samples from our blast hole. We go and do geophysical logging at our blast holes. We do peat mapping to define the geology and structure in a local scale. And then when the material goes through the plant, we again get chemistry and density through another set of sensors. We have sample stations, on-belt chemical analyzers, hyperspectral scanners. So as you can see, similar properties or same properties we are actually collecting throughout different stages the value chain. And as you go from left to right, your precision and resolution of the data increases. And at the same time, the uncertainty decreases. And for example, if you take just an elemental analysis, we can actually seamlessly follow part of the geology through the value chain. But unfortunately, many of data are not currently used in an integrated fashion. They are used a lot in isolation. The constraint inversion work, 3D modeling work that's being done in MinX CRC is a good example that we have started to use everything that we have. So once we can get to the stage, the value that our data can bring will increase. So by joining the dots between this data set, which is almost actually seamless if you think of it, only difference is that the scale varies. Um, Gravity, you can get the same density from gravity, then you get better density estimation or elemental analysis. So we can continuously actually improve our art model and ore body knowledge, and that hugely reduces the uncertainty. And this is where the data quality comes in. Before we can integrate our data well, we need to understand the quality of our data. Am I talking too fast? Is everyone with me?
Everybody is.
Great. So what is data quality? Quantity is also important, but I'll keep that for another day. So today, let's think about how can we make sure that our data can be trusted. So if I say what is quality, I would just say that quality is a measure of how well the data represent the property of the material or the specific property that is being measured. There are several facets to quality, and accepted quality varies depending on the purpose of the database. But however, it is very important to distinguish between various dimensions of quality and determine relative importance of those for that particular data set. Again, it's important that particular data set and what is the use of that data set. And again, um, quality at the end means fitness for use. Is the data fit for purpose? That's the question the quality answers. And remember, quality is always inversely proportional to variability. The higher the variability, lower will be the quality. So when we talk about quality of geosensing data, there are two aspects that's quite critical. One is the precision and the other one is the accuracy. So what is accuracy? So accuracy just means how close we are to the target value. In terms of assays, it means how closely the assay results represent the true grade of the sample. In terms of geophysical logging, for example, density, how close the logged value is it to the in situ density of the rock mass? On the other hand, precision is how repeatable or reproducible is the measurement. For geophysical logging, both repeatability and reproducibility is important. So repeatability measures the variation in measurement using the same tool in the same hole under the same condition. Whereas reproducibility measures the variation using a different tool under the same condition in a geophysical or geochemical sense. And it's important because if you think of in a mining operation, we will have multiple tools at various places measuring density. So it is important that each tool can reproduce the same data if we go and collect the data from a particular hole. And at the same time, each tool should be able to go and collect the data today and tomorrow and day after tomorrow and should be able to give us the same result. So that's why repeatability and reproducibility are very important for a geophysical tool. For geochemical samples, precision is how close is the measurement to the duplicate samples or triplicate if you can take it from the same pile. So these two are really, really important for geoscience data, accuracy and precision. And when we talk about precision, it means repeatability and reproducibility. And as you can, this is a very, very common diagram, just shows that, the data can be can have low accuracy, low precision, or high accuracy, but low precision, low accuracy, high precision, and then high accuracy and high precision. And depending on the use of the data set, the acceptability criteria will vary. If you really want very precise and very accurate data, it comes at a cost. So at the end of the day, it's always your cost versus the risk you can take. But we know why we need our data, and we have our criteria. What is our fit for purpose data set? But for that, we need a set of validation criteria and a validation process. So to ensure the quality of the data, we need to have a very defined QA/QC process. QA, as you know, is a quality assurance that refers to all the systems and processes in place to provide adequate confidence in the data collection. And then we have QC part, that's the quality control that refers to use of tools, mainly statistical tools, to ensure that systems are in control. So for each data set, we will need to know the data quality criteria that is important for that particular data set, for that particular use. For example, how accurately we need to know the 3D spatial location of the data. And that means your X, where is in the space, and also if it's a drill hole, which way the hole is going, and exactly from where your samples are coming from. And then how often you actually want it to be conformed to the plan. So does compliance to plan? Do you know the planned location and the actual location are same? How far, what is the variation you can live with? So in terms of sampling, what is the accuracy requirement for each element that we are saying for? For example, for iron ore, we have what we call big five: iron, silica, aluminum, phosphorus, and LOI. We need them to be more accurate than some other elements. Same with other commodities will have their own list. So we need to know for our purpose what is the accuracy and precision requirement. So the first step is that we define our acceptable quality. Then we need to establish a process how we can validate our each criteria. So for example, for accuracy, how do you actually define your accuracy? You need to have some standard, some certified reference material, or for geophysical tools, you need to have some blocks that has got what is the actual density of that block. So we do have standard, we do need standards, and we do need those certified reference material if we are looking at different grades. So, and then how often we actually take the measurements against those standards and blank. And then how do we check that measurements against our tolerance limit? So we need to have all these processes in place, the routines, the actions we have to take, regular actions to ensure that our data quality is under control. Same for precision. How many duplicate samples we have to take, and how many repeat logs we do for each tool and each measurement. So all these things has to be in place. Everyone should know, and everyone must comply with that. So once we set the criteria, then we can start validating our data. But important point here is that once the data is validated, it needs to have a home. And often we forget about that, where people can find the data and extract the data for further analysis. If it is in someone's laptop in an Excel spreadsheet, that's not going to work. So a database is a crucial step for good quality and reliable data. As I just mentioned, this is one of my pet hates. If the data is stored in multiple spreadsheets in people's laptop, some sort of USB drive, then there is no way to validate the data, and hence the data, we have practically destroyed the value of the data. So in summary, if we can establish a chain of custody for our data, know where our data is coming from, we can demonstrate the accuracy and precision, and we can extract our data from one source of truth, we are in a reasonably good place. This doesn't come free, but it is important to spend the money to ensure the integrity of our data. So why data quality is not negotiable? Data is what our resources are based on. I actually have learned a very important lesson on data quality in my final years as a master's student. I graduated long time ago, 25 years ago. Things probably have changed in India now. But as a final year student, we had a field camp and we collected gravity data. I can't remember what type of gravimeter it was, but all I remember that we collected some data, had lots of fun in the field. But after we came back and had to do our reports, then I realized, along with my classmates, that we couldn't make much sense of the data. It just simply didn't make any sense. And there was no way to go back and collect the data, unfortunately. So I remember the acute helplessness. At that time, more worry was the grade, obviously, the marking from the uni. But we had no idea of data quality. No one actually told us. It might have changed now, but I think it's really important to start teaching about the importance of the quality. The second one, as a graduate geophysicist, I remember I collected a huge amount of data, a lot of ground geophysical data, mainly in Rajasthan. I started my career in Udaipur, and I have walked through hundreds of line kilometers of frequency domain EM and magnetic data. And every day after coming back, I used to download and check data for quality for the simple reason that I did not want to walk those lines with a heavy instrument under the intense sun in the Rajasthan for the second time. But later, as I went through my career journey, I have gone through many painful situations to learn what happens when we do not pay enough attention to data quality. I just have got three examples. Few examples why we need to be so mindful. The one on your left is a pit wall failure. During the last 18 months, there were 5 significant pit wall failures in Western Australia, mines only. And these incidents, as you know, can cause a lot of damage to excavators, vehicles, and in these cases, there were near misses involving people as well, who were working in proximity to the walls at the time of the failure. And over the same time frame, we actually had 2 fatalities due to wall failure that occurred in New Queensland and in Queensland and in Northern Territory. And there's also been other near misses in New South Wales. So this is very real. I haven't checked what's the statistics in India, but I would imagine there would be examples there as well. So among other contributors, one stands out, and that is inadequate geotechnical information. So as you know, for geotechnical wall designs, we need structural data and also geological domain information, as well as rock strength. So if we do not check this data properly, or if the data is not quality control, then it can cause significant safety risk. So first is safety. Secondly, it's the reputation and financial loss. For a mining company, the revenue is based on the resources. Grade, tonnage, and material handleability informs most of our decisions of investment as well as the subsequent extraction. So if the tonnage and grade estimation that comes from our data, it sounds very simple. It comes from chemistry and your density and your geology. If it's not correct, it will have huge implication on the outcome for a particular mine plus the company. So when one of us taking a density measurement, it's very important that we ensure the measurement is correct and accurate and precise. So that's the second reason why quality is so important. But finally, it's big data and predictive analytics. This is kind of pretty much new, and it's a bit of uncharted territory at the moment. We all are learning about it. But what is big data? There are lots of definition of big data, but I kind of like the one with 3 V's. If the following 3 V's are present, I'll call it a big data. One is volume, where there is a huge big volume of data. Second one is velocity. It is the rate at which this data is generated or received. And the third is variety. Variety refers to the many different types of data that is available. Traditional data structures, as you know, are very structured, but with the rise of big data, it comes in all shapes and forms. So what happens then when we have all this data and we are trying to get more from our data? In exploration and mining, we collect heaps and heaps of data, but we probably utilize only a fraction of the data in the true sense. But with the big data, not just the big data, but also the fact that we have the computer facilities have changed. I remember when I started in ISM Dhanbad, there used to be one computer room, and we all have to line up and book to go and use a computer. But now it's changed. You can process huge amount of data at the same time. But with this comes a huge possibility that we can use predictive analytics to get more from our data. For example, if you have got exploration data and you've gone to the mining stage, you can actually use what we have learned from the mining and what we gathered at the exploration stage and try to predict from an area which is pretty similar, what we call analogous deposit. So you can actually then, without having to go through years and years of drilling, you can give a glimpse of how this deposit is going to behave if we plan a similar mine. So if you think of it, that's a huge benefit. But here comes the danger. If we are unsure of the quality of the data, how can we make decisions based on that analysis? So, there comes this huge possibility, but it also brings this onus on us to make sure the data inputs going to those models are actually good quality. So that's why I think in this today's world that the data quality is becoming even more crucial and just so completely non-negotiable. That's all I had, and I was just looking for gravity images today. Just I wanted a colorful picture. In 1997, to get a gravity image in the internet over India would have been impossible. But today, I could just search and get it. So just think of all the free data we can have and things we can do. But if everybody takes care of the data and make sure that the data behind these images are good, it will help us decrease the risk of whatever analysis we produce and will help with the improved decision making. So yeah, thank you all for your time today.
Thanks, Asmita. Now we leave the forum open for questions. But before that, I would just like to highlight what Asmita has said today. Basically, being a data scientist and especially in geoscience area, we are lucky to have her, and she has been exposed to lots of varieties of data. Her main takeaway, which I see, is that from the Asmita's talk, being importance of quality and how we capture the data at the source. Now, I can just give you an example, which I was other day discussing with somebody, is that though we collect data in field, we do geology, we do geochemistry, we do logging and every stuff, but we hardly collect at the time of exploration a geotechnical data, which actually is needed when you are doing a designing of mine or you're doing a pit design or something. So at a little extra cost at the initial stage, if we could gather the geotechnical data, which may not be useful on the same day or in the same period, may end up being useful when you are opening a mine or you're planning to mine closure. So that's something which is a very important takeaway from Asmita's talk. And I leave the forum open to any questions. If anybody has any questions, please feel free to come and unmute your mic and you can speak out.
Okay, good morning.
Please identify yourself before you ask a question, because this being virtual, it's a very difficult to know who it is. Okay. There is a question from Anand Prakash. I will read out. Is there any reference to check accuracy in geophysical survey, for example, gravity survey, as we can see the precision checks during the survey, but please explain about the accuracy.
Okay. With gravity survey, we have got several ways how we can actually check the data we are collecting is as good as it can. I haven't taken a gravity measurement for a long time, but if I think back, the first is that you make sure that your instrument is leveled. You have then go back and collect the data at your base station. You collect your repeat measurement. So those are the things that will tie back to your data accuracy and precision. The gravimeters will always come with its own the tolerance of the tool or precision of the tool within which it will operate. And often we have a workflow for your gravity measurements as well. So And then again, your processing step, you will have your QC steps as well.
Yeah, Dr. Samuel, please go ahead.
Asmita, in the mining value chain, in your opinion, where at what stage you think data quality is heavily compromised? I'm talking about irrespective of the country, irrespective of operation size and brand. It doesn't really matter. But it's something bothers me every time I look at a reconciliation. I look at a a resource reserve type of problem I have. Where you think in the entire value chain, but where it is actually heavily compromised, or not really heavily compromised. It's compromised if you compare to exploration to from upstream exploration activity to collecting the data at the plant. I think that's what is your observation in your career?
The reason I'm so passionate about the quality is that often we see that at the very beginning, at the resource definition stage, not always we pay the attention we should be paying to our data quality. We drill a lot of holes, and that kind of sometimes compromise the quality aspect. The other thing we don't often do is that at the blast, when we go and drill the blast hole sampling is heavily compromised. If you think of it, we actually don't know where your samples are coming from. So that's around the sampling side. But again, in a geology mapping as well, often we do collect data, but then we don't go and do reconciliation of our models. So that's the other area where we don't actually pay attention to the quality of our data.
Yeah, thank you, Asmita. I think this is definitely, I wanted to your experience because I've never been to Australia. Done so many works from Australia, but been there. But I agree with you. But I think with little deviation there, in my experience, the exploration data is probably better. We have better control on the quality. But the worst part is when operation blast all data.
Yes.
Who project? I will not name the project. Some of them are really it's amazed me, irrespective of the type of people they have. It's a powerful data. The 2 points actually for the entire audience. One is how you collect it. Starting from collection to lab checks. The moment own experience, the moment I start asking the question about the lab, the on-site lab quality versus the the commercial lab quality comparison, I see the on the other side, the people on the operation, I see a little bit of lack of comfortness in there, and that I think that's where I spend a lot of time. And this is such a fascinating topic, and irrespective of our discipline, like geophysics or geochemistry, or mine production, whatever. I think this is a very important. Not only that, actually, particularly when a mine goes into production, somehow we lose track. But thanks for that comment.
Yeah, I think labs are not usually, I usually find labs are not the issue, but it's the how we take the sample. with blast holes, the sample representativity is the big problem, because if you think of it, blast hole is not designed for collection of samples. It is designed to put the to blow it up. So if you have seen a blast hole, it's like a cone. On the side of the hole, you see this art falling. So you kind of take the sample thinking that, oh, this is coming from 0 to 12 meters, 0 to 4 meters. This is coming from 4 to 8. This is coming from 8 to 12. But in reality, you actually don't know where it is coming from. And that is one of the biggest source of uncertainty, because the sample representativity is very poor.
We have another question from Dana. She says, thank you very much. I'm just reading her comment. Thank you very much for the presentation. As you said, there are lots of different software tools to store the data. What would be the way forward? What would be the way forward for all the teams to share and view the data? Some universal viewer tools, CSV files, or etc., or Python tools, something else. So her question is basically, she's asking how the data should be stored and shared between the team, and is there any something which is universally useful?
You're asking a really good question, because as we're moving forward, we have to start thinking about that. Within organizations, we have different databases, SQL Server, Acquire database, different names, but based on various platforms. But as we go more into all this cloud computing, big data, we have to start as an industry thinking, what is our common platform for data? So that is going to be very, very important going forward.
I have Masood. You have some questions for Asmita. Please come in, Masood.
Yes, sure. Thank you, Asmita, for the presentation. I enjoyed your talk. One question that I have is that in this space of data quality and data assurance, how is mining progressing comparing to other industries? Where are we in that journey? And is there a space for a best practice of data quality and assurance?
Thanks, Masood. We could have been sitting in the same place.
Yes, exactly.
You're probably the only person in the same geographical location as me. It's a really good question. Mining, in terms of data quality, I would say that we have still a lot of work to do. Over the years, I think we have become more and more serious about data quality, but I wouldn't think we are there yet, because of the fact that we can get away with less precise and accurate data. If you think of it, for example, who was talking about the blast hole sample? The only reason we can get away with blast hole sample because we collect so many of them. So compared to oil industry, for example, we are miles behind, because for them, they drill one hole, which is very expensive, and they have to make sure that data they get from the hole is as best as they can. So we are not there yet. We have to do a long way to go. And if we want to harness the power of data analytics and big data, we have a lot to catch up.
Thanks, Asmita.
Just to add to what Asmita said, this is something which I keep saying during my talks also, is that geoscience data is the only data which never dies. Every data, other type of data has a shelf life, whether you look at banking or transactional or anything. So geoscience data is the only data which never dies. So quality of the data when you are acquiring can be is very, very important because it could be used after 100 years. And still it speaks the same what it was on the ground 100 years back. So this is one thing which is very critical. We need to understand when we are talking about data storage and data quality, that this data could be used by other generation who we can even not think of feeding, but the data can be fed to them and they can find a resource from that data.
The hotel room.
Any other questions? Anybody else has any questions? Vikas, yeah, go ahead, Vikas.
Yeah. Hello, ma'am. Vikas here. Ma'am, thanks a lot for the presentation. It was very nice. Ma'am, I don't have a question as such, but as a request, like coming back to all the questions which were coming up earlier. See, like as you said, QAQC plays a very important role wherein we need to in terms of exploration, we need to know like exactly what CRM we are putting, what duplicates we are putting. But as in the industry, like even let it be like Crisco or JOC or any of this code, they don't tell you exactly what QAQC you have to do. Like if at all, if you are putting CRM, what should be the standard deviation which should be there? What should be the duplicates after which you cannot allow? So ma'am, like it was just a request, if at all, maybe in future, we can have a session like from you or like some papers or something wherein we can discuss about this. Like what standards like you all have been following, and like we can have a discussion like what we have been doing it over here, ma'am. Anything possible?
Yeah, it is possible. I can actually get people in my team who works specifically on QAQC data, etc. Because JORC, and if you think of JORC, it's a very broad guideline to make
Exactly,
sure
ma'am.
to keep you honest. So that's what it is. So how you interpret, how you put measures to make sure that you meet that criteria, that's kind of left to you. But that's a good topic. We do need to have, especially, for example, I'll talk about this downhole assay tool. You know, we have now the PFTNA tools. In the upcoming iron ore conference, you'll actually see some papers on that. And that's being used in grade control. It's a new tool. So as an industry, how do you define the quality? And as you said, that how many CRMs blanks. So I think we do need to have some industry standard, which we don't have at the moment, but every company does their best to make sure that they can meet the JORC guideline.
Yeah. Thank. That's what, ma'am. Like it would be best if you can get more people and we can have a good discussion on this maybe sometime in future. So looking forward to that.
No, sure.
Dr.
Thanks,
Samuel,
ma'am.
Dr. Samuel, you had raised hands. Do you have anything, or it was just?
I think Asmita addressed that nicely.
Yeah.
Any of the Crisco course you go, these are guidelines or course or whatever you say. They will tell you this cannot. The first thing about this course or guidelines that they cannot be prescriptive. Remember, a country has a code like in India we have IMIC, and Australia we have JORC, and Canadian here NI particular one. Anyone you take, there's always two things. One is these guidelines or codes they can only see, that's meant for the whole industry and not that's why we don't have it. And the second thing is, and this is vital actually, what Asmita also taught, every big company you go, MC big company, because small companies they really don't know many times they don't know. They would always have some sort of internal guideline, like we used to have, like how many, at what frequency there should be a a standard or a blank should be going. So what I'm hinting at, if you go to some of these publicly available reports, it's on your own interest, which I did many years ago. So what is done? And also, and then you will get an idea, like, like here in Western US, to go to the gold properties or some of these coppers also, like, every 20th, something like that, they would say. But it really depends on the type of commodity you are dealing with, the type of geology that you have, what kind of complex situation you have, but simple situation that you have. What I'm saying is, if you are inserting a, any sort of things, like, whether it's a duplicate or you're doing a blank or something, or a CRM, something that you are doing every 20th for iron ore, it's maybe every 10th for a vein type gold deposit. It really depends. But it's a fantastic topic to have a good discussion sometimes. I'll really look forward to that. Sometimes if you guys actually, KK, you are arranging this thing sometimes in the future. But that's a fantastic, great comment actually.
Surely, sir, this suggestion has been noted, and we will surely like to have kind of panel discussion in this case. Not just a speaker, but would be we will organize a panel discussion in near future, wherein people can surely share their experiences, and we can have a good talk. I think with all the questions over at this point of time, I would like to thank Asmita a lot. We are quite grateful from Dataport that you took out your weekend and a Saturday for us to enhance our knowledge and experiences which you shared. We are obliged. All the listeners are surely, I'm sure they would be happy to, and there is a takeaway from this talk for them. So thanks, Asmita. We look forward to having more such talks from you and other members of this group. Thank you, and really appreciate your support.
Thank you.
Yeah.
Bye then.
Thanks.
Bye.
Bye.
Thank you.